Okay, so we were discussing how to calculate for each cost the corresponding net present value, the present value of each cost. So we have for these two. So for these two costs which are at year one, all we have to do is to consider here. One second, just to fix the annotation. Okay. Okay, so here for year one, the present value of this cost will be 0.9 over 1 plus A, which is 18%. So 1.18 to the power 1. The formula used here is exactly the same, but now we should add to 0.9, we should add plus 0.5. Now, for this value, here we have two strategies, okay? One strategy will be to determine costs for each year. I will show you an Excel sheet that I developed. Of course, in the exam, we'll not have the access for an Excel sheet. So we can do it manually, okay? But the idea is the following. I have two strategies. The first one, so let me open the Excel sheet to show you. The first one can be to divide costs for each year. And I list the costs that I have for each year. Okay, so I can say I have from year 0 to year 10. According to my given, for each cost I determine, and for year 0, I just have $0.5 million. For year 1, we have already 0.9 plus 0.5. If we continue reading our problem, we have $1.5 million. And this $1.5 million, we have to pay it for year 1 and for year 2. Okay, so one strategy will be to calculate year per year. Another strategy is, if I have, for example, something to pay in year 1 and in year 2, and we have the same value, let's say 1.5 for year 1 and 1.5 for year 2, I can do summation for I from 1 to 2 of 1.5 over 1 plus A, which is 0.18 to the power I. Okay, so, or if you want, I do the analysis per cost and I apply summations, which can be done here, or I decompose my costs per year. And I say in a table, I summarize what are the costs paid in year 1, in year 2, in year 3, etc. Once I am done, and this is easily done, with your Excel sheet, you can do this easily. You just have to enter the information. Now, after we'll see that we have a lot of costs between year 3 and 10, and with an increase in cost, or in percentage, or in a constant value. Okay, so here's the values 0.5, 0.9, 0.5, 1.52, etc. are values that are specific for a certain year. But here in the list here, I have, for example, if I go back to the given, okay, so here, as we said, I can list in year 0 only 0.5. I can list in year 1, 0.9, 0.5, 1.5. And also here, this information also is for year 1. I have $2 million for year 1. Okay, so this is for year 1. That's are the costs that I need to consider. I move now to year 2. For year 2, I have 1.5, 1, 2, okay, 1.75. And here marketing in second year also, it's 8. So I can list these prices, these costs for year 2. Now I can move to my year 3. Okay, for year 3, it's here I have some complex analysis to perform because from 3, I have several information from 3 to 10. So how to deal with it in my Excel sheet? I can say, for example, here, I have to consider $200,000 for year 3 with a 4% increment per year thereafter. Okay, so here this means that for year 3, under year 3 in my Excel sheet, I will just put 0.2. If I do the analysis in $1 million, I divide by 10 to the power 6, so 0.2. Okay, now what do I have here? Each year I will multiply by 1.04. Okay, so I can, in my Excel sheet, do a general formula. And the general formula will be the following: 0.2 times 1.04, okay, times the number of year ends that I have minus 3, okay? So if you have, for example, year 4, you will just multiply by 1.04 to the power 1. For year 5, it will be 5 minus 3, so 1.04 to the power 2. And in Excel, you write the formula once, and then you can find costs for all remaining years. Okay, and if you want to, if in the exam you have just to do calculations for 2 years or 3 years, you can do it in this way. You can calculate, you multiply by 1.04 for each year. Okay, and then you will have in your Excel sheet here, okay, this is the formula I used, so you can see it here. I considered that at year 3 it's 0.2. Now for year 4, I just write the formula in Excel: 0.2 times 1.04 to the power the number of year, which is F1, okay, minus 3. And now you just drag your pointer, and then you can get the values for all remaining years. And you just have to implement the formula once, and you can get for all remaining years what will be the cost. Okay. Now, another information to implement in your Excel sheet, you have also that from year 3 to 10 for marketing, you should consider $5 million for year 3, and each year you will reduce 0.2 million per year thereafter. Okay, so here, what is new here, it's not a percentage. You don't have a percentage to add or to reduce. You have a constant amount to reduce. Okay, so it's also simple. You can write the corresponding formula. For under year 3, you can put 5. And then a general formula to put for a year n after year 3 will be 5 minus 0.2 times n minus 3. So if you are in year 4, you just deduce 0.2 once. In year 5, it's minus 0.2 times, here n minus 3. 5 minus 3 equals to 2. So minus 0.2 times 2, etc. So in this way, you can fill your sheet between 3 and 10. So you just have to put 5 here. And then you put the general formula for this cell, summation of 5 minus 0.2 times the number of year minus 3. And you drag it to find what will be the values. Here it's relatively simple. You can do it by hand. It's very easy. You just subtract 0.2 each year, 5, 4.8, 4.6, etc. Until year 10, it will be 3.6, which is 5 minus 7 times 0.2, because you have to reduce 7 times 0.2 from year 3 to year 10. Okay? And in this way, you can fill this row. Now, another information to include. So here, they said also that we have a new equipment, to purchase new equipment. Here, guys, the given should be very clear, okay? If they put in general a slash like this, or year 4 to 8, this means I should consider 4, 5, 6, 7, 8. If they just say 4 and 8, okay, this means that I don't have to purchase in between. For the homework, don't. It's not a problem. I will consider it, and if some students considered from 4 to 8, I will take this as true. But pay attention for this, okay? So when they put slash, when they put, let's say, this symbol, or when they say from 4 to 8, or per year, yani if they say per year for each year from 4 to 8, then you should consider all years in between. If they just specify 4 and 8, okay, you don't consider years in between. And here, because they said 10% thereafter, it was a little bit misleading. But they should be clear. They should tell us, for each, if you want, instead of thereafter, they can just say for next purchase, if you want. So if at year 4, for the first purchase, it was $2 million, the second one, which is at year 8, is just, we should add to it just 10% of the value. This means that in the column of year 4, you just have to put 2. And in the column of year 8, you just have to put 2 plus 10% of 2, yani 2 times 1.1. So in year 8, you should put in its column 2.2. Okay? While in the column of year 4, you just have to add 2. Okay? Now, for the last information, we have human resources will consider 100 new employees for 2,000 hours per year between years. So as you can see here, from 3 to 10. Okay? And we have $20 per hour for year 3, and then 5% per year. So since they said 5% per year, so it's the same formula to apply as we did here in the 4% per year. Same formula, just the numbers changed. So here we have the cost per year for year 3 is 100 times 2,000, which is the number of hours, okay, times the cost per hour, which is $20. So we get $4 million. So now we should say, in column 3, we should put, under column 3, we should put 4. And then after this, we should put a formula from 3 to 10. So we multiply each year by 1 point, so times 1.05. Okay? And then we can obtain in our Excel sheet the corresponding costs from year 3 to year 10. Finally, we have the phase out and disposal costs for years 9 and 10. So it's $1 million per year. So all we have to do is to put under the column of 9, 1, and under the column of 10, 1. So this is the table summarizing costs. Okay. So after you do this, you can sum for each column. You can sum the values for each year, okay? But these costs, here's this summation here. So this is the summation, okay? 4.9 represents the summation of all costs for, if you want, that should be paid at year 1. But as you know, since we want to calculate the life cycle cost, we need to evaluate the total cost per year. We should take it back to present. So after we do this summation for each year, to take it back to present, what should we do? We should divide it by 1 plus 8 to the power I. So all you have to do is to include the formula here. You take each element of this row, you divide it by 1.18 to the power number of year. Okay? And then once you do this, you are able to evaluate all your costs at one time, which is the present time. Now you are ready to do the summation and to obtain your LCC. So here your LCC will be around $45.38 million. Okay? Now, this is a first method, but it's not the only one. So here, the first technique is to consider costs for each year. Okay, then we apply the formula of dividing by 1 plus 8 to the power I to find the cost at present, and then we sum costs. Another technique is to consider for each cost, okay, to take it back to present. And here we can use the formulas that we developed together in the course material. And for example, if you go back to our given, Okay, so here, as we said, whenever you have, let's say for year 1 and 2, you do summation. So to assess the cost of equipment cost, you do summation. Here, because it's just from 1 to 2, and no need to apply the summation. You can just divide in 2 terms. And you say 2 over 1.18 to the power 1 plus 2 over 1.18 to the power 2. It's easy. No need to apply summation. But if we consider here, for example, okay, I have from 3 to 10. It's easier to apply summation instead of doing calculation of terms, instead of dividing into several terms, yani at year 3, 4, etc. So you will have 8 terms to consider then if you want to do summation. If you want to decompose at year 3, yani I take 0.2 over 1.18 to the power 3 plus. But here you should pay attention. What is new here, you don't have only the discount rate. Yani you have the discount rate to take it back to present, but you have also to take into consideration the 4% increase. Okay, this is why here we need to modify a little bit the formula that we are used to. How to do this? It's very simple. You can consider the following. You can say that actually what I am doing, I am starting from year 3. Okay, so for me, I know that at year 3 I have 0.2. Okay, so it's like this. Instead of starting analysis from year 1, I'm starting from year 3. So if you want, you can say that if I start from year 3, I can consider first that I can evaluate the value at the year just before, at year 2. And instead of going, for example, from 1 to 0, I can evaluate the total cost first at year 2. Okay, because everything is starting from year 3. This percentage variation, okay, is starting from this year. So if I want to divide, if you want, what I will do, I will first say from now on, I will multiply by 1.04 each time, and I will divide by 1.18. Okay. So since I'm doing this from year 3, I can evaluate, if you want, at year just before the total value, and then I get after getting the total value for the year just before, I can take it back to present at year 0. Because if I have the value at year 2, to go back to present, I just have to divide by 1.18 squared. Okay, so you can do this. You can try to play with your formula to make it to make you use the summation as you are used to do it. Okay, I will repeat. So the idea is the following. You are doing a strategy now from 3 to 10. Okay, you consider that this is year 3. I have the cost here. I know it's 0.2. Okay, so now from year for the remaining years after year 3, 4, 5, 6, etc., what should I do? I am multiplying by 1.04, and I am dividing by 1.18 to the power. So if I consider year 4, what I will do, if I will go back, if I want to assess the cost back to year 3. So back to year 3, I will just multiply by 1.04. And then if I want to take it back to 3, I will divide by 1.18 to the power 1. Okay, so it's like, if you want, year 3 now is my initial year. Instead of considering year 0 as my initial year, I can evaluate all my costs back to year 3. And once I do this, once I evaluate all my costs back to year 3, I can then evaluate these costs back to year 0. Why I am doing this? Because I am starting to do the strategy, this increase of 4%, okay, and the division of 1 plus A from year 3, okay, I am doing them as considering that this is my starting time. Because I'm not doing 1.04 for year for the previous years, okay? So one strategy will be to do this method. Or if you want, you can do the methods that we learned together in class. And you can say the following. After year 3, so year 3, 4, 5, etc. What I am doing, each year, I am multiplying by the cost that I have by 1.04. And I am dividing by, if I want to get it back to year 3, okay? I am dividing by 1.18, okay? So it's like if you want, I consider a new value, instead of considering the value of A equals to 1.18, so the value of A now is 1.04 over 1.18. Okay, and I will do, my summation will be, I will do summation for I going actually my summation is from 3, okay, because here before this year I'm not considering this, so I do summation from year 3 to year n, okay, of what I am doing now is that for each year I am considering to multiply by 1.04 and to divide by 1.80. Okay, so I have my cost. The cost that I have is, let's say here, it's 0.2. And I will do times this 0.2 will be times 1.04. Okay, here if you want, because over 1.18 I am assessing it from here. Okay, so this is my, if you want, starting point. I can consider that like I can modify my equation because the value of 0.2 is just evaluated at year 3, not before. Okay, so instead of summation from 3, I do summation from 1. Okay, and I have 1.04 over 1.18 to the power I minus 1. Okay, so this is the formula that I am using here, because the base number that I have, which is 0.2, was at year 3. So my reference now is year 3. I started to do the increment of 1.4%. I'm not doing from the beginning. Before, in the strategy that we learned together of summation, when we applied, if you want, minus the 2 first terms, we were able to apply it because we divide by 1 plus 18 to the power I starting from year 0. But here, this 4% increase didn't start from year 0. So this is why we are not able to do the manipulation of summation. And we are used to do what? We write summation from 3 to n. And we directly put, what was our summation? It was equal to 1 over, or the cost, if you want, over 1 plus A to the power I, okay? Because here, we can do it to the, if you want, to the power I, because we are getting back to year 0, and it's this discount rate is accounted from year 0 to now. But what is different here is that the 1.18%, we account for it from year 0. This is discount. But the 4% increase is just considered after year 3. That's why we cannot apply the usual method of doing that this summation can be written as summation from 1 to n minus the first 2 terms. Here it's not applicable. What we should do here, we should, like, if you want, get first if the values, the corresponding value at year 3, okay, and then take it back to present at year 0. If you don't want to do to use this complex formulation, all you have to say is that I can apply the technique of summation, as the same one as we did in the Excel sheet. Because here, of course, if you have taken already economic courses, you have developed in these courses formulas that can work for all of these scenarios. And you have a formula that can directly give you, if I have 4% increase, what is after year 3, what is the formula I can use? So if you have taken these courses, I don't mind if you use formulas, you can do it, okay? But if you don't want to complicate things in your mind, because for each specific case, you need to apply a specific formula. And here, if you impose a percentage of increment after year 3, you have a certain formula. If you impose a certain constant reduction or constant increment, you have another formula to apply, okay? So in case you don't want to, you didn't take this course and you are not aware of these formulas, it's not a problem. And they are complex and you don't have to remember them. That's why you can, if you want, do some reasoning, and you can develop your own formula. It can be done. It's not complex. So all you have to say is, if you do a small analysis here, you can say, let me consider for me that year 3 represent for me, if you want, the reference year. Okay, so this is my reference year. If I consider this is my reference year, let me evaluate costs back to year 3 as the first step. Okay, and once I do this, if I have a total cost at year 3, I can easily take it back to year 0. Okay, because if I am able to evaluate back my cost at year 3, to go to year 0, I just have to say this cost at year 3 will be divided by 1 plus A, the discount rate, which is 1.18, okay, to the power 3. Now, how to evaluate my costs back to year 3? If I consider year 3 as my reference, okay, then what is the summation that I will do? If I consider, if you want now, 3 is year 0 for me. So if 3 constitute year 0 for me, okay, year 4 will be for me year 1, year 5 will be year 2, okay, etc. And year 10 will present for me year 7, okay? And I want to do summation of these costs, okay? So I have to do summation for I from 0 to 7, okay? If you want, the formula that we developed is summation from 1, because the formula that we developed in class, if you want to apply it, it should be from 1. We consider that here we have from 1, I do summation from 1 to 8, okay? Now, what I am doing, I have a certain cost. This cost, what should I do with this cost? I should multiply by 1.04, okay? and I should divide by 1.18. Okay, and to the power I minus 1. Okay, so this is my geometric expansion that I will use. Here, but instead of having I have I minus 1, I can give you a formula to be able to apply the geometric series. Okay, and in this way, you can evaluate the total cost at year 3, and then deduce, after you evaluate it at year 3 from the summation, you can take it back to 0. Okay. So, or we use such techniques with formulas, or we use the Excel sheet. And after we do this, we'll be able to find by summing all costs for all years, we'll be able to do the summation over the lifetime and get the total LCC evaluated at present. Okay. Any question on this problem?
Okay.
Okay. Another problem. Okay, so for problem 4, we had a small, it was a little bit tricky because the values were really unpredicted. In general, not always you will have in problems profitable projects. So in case you get NPV negative, it's not, this doesn't mean that you have an error. It might be. So whenever, if you get a negative NPV, you say this project is not profitable. Okay. So a sole source vendor can supply a new industrial park with large transformers suitable for underground utilities and vault type installation. Type A has an initial cost of $30,000 and a life of 10 years. Type B has an initial cost of $55,000 and a life expectancy of 10 years. The annual operating cost for Type A is expected to be 2% of the initial investment and will lead to increase in income for the industry for $6,000 for year 1, $5,000 for year 2, and $4,000 for the remaining years. The salvage value for Type A is $5,000. The annual operating cost for Type B is expected to be 1% of the initial investment and will lead to increase in income for the industry of $9,000 for year 1, $8,000 for year 2, and $7,000 for the remaining years. The salvage value for Type B is evaluated to be $10,000. So we have two types of if you want, of projects, and we need to compare them. Okay, so as usual, we know that the internal rate of return and the CER in general are indicators that can help us to select the most appropriate one. Okay, now in this problem, if you want, if I don't ask you questions and if I just give you this problem and I want you to make judgments, you can always, one technique that we use to facilitate, if you want, the selection is to try first, if we don't consider time effect, if the project is profitable or not. Because if we don't consider time effect and already we got bad results, we can stop from here. And no need to continue and to do calculations, more calculations, because calculation of internal rate of return and CER are not straightforward. I need a formula, I need to do trial and error, or I will have a big formula to introduce in the calculator, etc. So in case I want to do fast calculations to have an idea about my project, I can start with not considering a time effect. I will do with you this, if you want, to see in reality how we can reduce the time of comparison. Okay, so in general, when we want to study a project, the best approach can be to start to evaluate non-discounted payback period, because it can be an indication. And if already the non-discounted payback period is large, if it's already large, maybe you will stop. If the non-discounted payback period is larger than 10 years, no need to continue. Whatever you do, whatever you take, whatever discount rate you take will give negative NPV. Okay. In case it's very close to 10, also you can say, I expect that this project is not viable, because if the non-discounted payback period is 8 or 9 years, so the discounted payback period will be much more, and it will be larger. Higher the discount rate, higher the payback period. So I can say that if I get a non-discounted payback period close to 10, I don't continue with my calculation. I say, let me stop here. Okay. So here we didn't do this. That's why we obtained the results and we were surprised. And maybe we did a calculation error. No, it can be. Okay. So if I want to evaluate in a fast way, if you want, to start with my analysis, I can put my, let's say for type A, okay? For type A, I say, I have, the initial cost is 30,000. So I can put, let's say NPV, if we don't consider, so for a discount rate, if you want, of 0, I will not consider the discount rate. So I am considering non-discounted payback period. I want to try to find what is the number of years needed to pay back my money. So I can write that my initial cost is minus 30,000. If you want, let us simplify thousands, yani minus 30. So the result is times 10 to the power 3. So minus 30. And I have, the lifetime is 10 years. So I need, when I evaluate my payback period, it should be much smaller than 10 to be encouraging. Okay. So I have that the annual operating cost for type A is expected to be 2% of initial investment. So if I do 2 times 30 over 100, so it's 0.6, okay? 0.6 for all years, okay, here. So minus 0.6. So since it's constant with years, okay, I just multiply, for each year it's 0.6, I multiply by n. Okay, while for the incomes, the income is varying with years, okay? So I have, for year 1, it's $6,000, so plus 6, because I divided by 10 to the power 3. Plus, here, since I